Hi guys, welcome back again to my another video. So for today's video, we're down to the chapter 6 and let's start the video. Chapter 6 summary. Chapter 6 network layer. The section in chapter 6 is network layer protocols, routing, routers, and configuring a Cisco router. Network layer protocols. The network layer, which resides OSI layer 3, provides service and allow end device to exchange data across a network. The network layer uses 4 processes in order to provide end-to-end transport, addressing of end devices, encapsulation, routing, and de-encapsulation. Encapsulation has the protocol data units from the transport layer are encapsulated by adding IP header information including source and destination IP address. The encapsulation is the destination host to encapsulate the packet to see if it matches its own. Network layer protocols. The network are several network layer protocols in existence. However, the most commonly implemented are Internet Protocol version 4 and version 6 or IPv4 and IPv6. Encapsulating IP. The network layer. IP encapsulates the transport layer segment by adding an IP header for the purpose of delivery to destination host. The IP header stays the same from the source to the destination host. The process of encapsulating data layer by layer enables the service at different layers to scale without affecting other layers. Routers implement different network layer protocols concurrently over a network and use the network layer packet header for routing. Characteristics of IP. IP was designed as a protocol with low overhead. It provides only the functions required to deliver a packet from the source to a destination. An IP packet is sent to the destination without prior establishment of a connection. IP was not designed to track and manage the flow of packets. This function, if required, are performed by other layers, primarily TCP. IP connectionless. IP is a connectionless protocol. Very similar process as sending someone a letter through snail mail. Senders do not know whether or not the destination is present, reachable, or functional before sending packets. This feature contributes to the low overhead IP. Best effort delivery. IP is a best effort delivery. IP media independent. IP operates independently from the media that carries the data at lower layers of the protocol stack. The OSI data link layer is responsible for taking the IP packet and preparing it for the transmission over the communication medium. IPv4 packet header. An IPv4 packet header consists of the fields containing the binary numbers. These numbers identify the various settings of the IP packet, which examined by the layer 3 processes. Version. Significant includes field includes version, differentiated services or diffserv, time to live, OTTL, protocol, source IPv4 address, and destination IPv4 address. Limitation of IPv4. IPv4 has been updated to address new challenges. Three major issues still exist with IPv4: IP address depletion, internet routing table expansion, lack of end-to-end connectivity. Introducing IPv6. In the early 90s, the IETF started looking at a replacement for IPv4, which led to IPv6. Advantages of IPv6 over IPv4: increased address space based on 128-bit addressing versus 32-bit with IPv4. Encapsulating IPv6. The IPv6 header is simpler than the IPv4 header. Encapsulating IPv6. Advantage of the IPv6 over IPv4 using the simplified header. Simplified header format for an efficient packet handling, hierarchical network architecture for routing efficiency, auto-configuration for addresses, elimination of need for network address translation between private and public addresses. IPv6 packet header fields: version, traffic class, flow label, payload length, and next header. IPv6 packet header fields: hop limit, source IPv6 address, and destination IPv6 address. Routing. Host forwarding decision. Default gateway. The default gateway is the network device that can route traffic out to the other networks. It is the router that routes traffic out of a local network. This occurs when the destination host is not the same local network as the sending host. The default gateway will know whether the send excuse me, packet using is routing table. Using the default gateway, a host's routing table usually includes a default gateway address, which is the router IP address for the network that the host is on. Host routing tables. On a Windows host, you can display the routing table using route print netstat. Three sections will be displayed: interface list, IPv4 table, and IPv4 route table. Router packet forwarding decision. When a router receives a packet destined for a remote network, the router has to look at its own routing table to determine where to forward the packet. The router's routing table contains directly connected routes, remote routes, and default route. Router routing table. R1 this will be the example of router directly connected routing table entries. You have the C and the L. The C identifies the network is directly connected and the interface is configured with an IP address and activated. L identify that it is a local interface. This is the IPv4 address of the interface on the router. Understanding the remote route entries. So that will be the remote route entries. The next hop address. When a packet arrives at a route destined for a remote network, it sends the packet to the next hop address corresponding to the destination network address and in its routing table. Routers. A router in a computer. A router is a computer. Like computers, a router requires a CPU, an operating system, and memory. Cisco routers are designed to meet the needs of wide variety of business and networks. Branch 1 service provider. Router CPU and OS. Like computers, Cisco routers require a CPU to execute OS instructions, including system in, in initialization, routing functions, and switching functions. Volatile router memory. The anatomy of a router is a router memory. Volatile memory, non-volatile memory. A router uses four types of memory: RAM, ROM, NVRAM, flash. Inside of a router: power supply, cooling fan, SD-RAM, non-volatile RAM, CPU, heat shields, and advanced integration module. Connect to a router. Enhanced high-speed WAN interface card, auxiliary console port, gigabit Ethernet, compact flash slots, USB port. LAN and WAN interface. Cisco router connection can be classified into categories: in-band router interfaces, management ports, packet tracer, exploring internetworking devices. In packet traces activity, you will explore different options available on internetworking device. You will be required to determine which options provide the necessary connectivity when connecting multiple devices. Cisco routers and switches load the iOS image and startup configuration title into RAM when they are booted. The running configuration is modified when the network administration makes any changes. These changes should be saved to the startup configuration file in NVRAM in order to router boot process. It has three major phases to boot up process of a router: perform, post, and load bootstrap program, locate and load Cisco iOS, locate and load startup configuration. The shows version output. Cisco 4 configure a Cisco router. Basic switch configuration steps. Cisco routers and switches have many similarities in regards to their configuration. Basic router configuration steps. Configure router interface. 2 GB Ethernet interface, 1 serial 1 interface card with 2 interface. The command in the figure to the left provide an example of how to verify interface configuration. After configuring an interface or for troubleshooting purposes, there are several commands that can be used. Show IP interface brief, show IP route, and show interface. Default gateway for a host.